Good afternoon, everybody. Now I am presenting the triple T diagram through these PPTs. So first of all, I have to show these PPTs through which you can uh, basically understand what is the triple T diagram and how the triple T diagram is to be directed. First of all, in the triple T diagram, there are two axes. In the left-hand axis, this denotes that's the temperature, and mm, this is the x-axis, which is shown by the time. Now, the question is that what is the significance between temperature and time? It is because the material properties, which is to be shown in the iron carbon diagram, it is very correlate with the triple T diagram. In this diagram, first of all, the steel, especially it is denoted for the steel which is heated at a certain temperature. When the phase is to be transformed from one phase to another phase, and then again it is to be cooled at a certain temperature with a certain period of time at a certain atmosphere. So the transformation will be occurs. So first of all, in the triple diagram, there are two phases. Left hand side it is called the austenite, and right hand section is to be divided into three sections. This is the pearlite, this is the benite, and last one is the martensite. Now, in this triple T diagram, the left hand side, when the metal is to be heated from the 0 degree temperature to the 723 degree temperature above, especially it is 768 degree centigrade, when the phases is to be transformed from um, BCC structure to FCC structure. Now the gates, we now gets the phase in is austenite. Then the austenizing temperature, when the material is to be heated, then it is to be cooled. By the help of triple T diagram, we can easily identify when the time is to be considered at a certain period of time phases. First, from the austenite, when the temperature is to be constant and the time is to be changed at a longer period. The x-axis, easily we can see that the log time, it's maybe hours, it may be second, it may be minute. If we increase the time period, then the phases is to be transferred and the metal is to be cooled very slowly. So slow cooling is to be occurs, and austenite is to be transferred into the pearlite. Into the pearlite, there are three types of pearlite which especially we are see. This is first one is the coarse pearlite, second is the medium, and third one is the fine pearlite. In the coarse pearlite, the metal structure is very fine particles are there. So obviously the hardness of this metal is very high. And then when the temperature is to be decreasing, then the property is to be downfall. So in the left hand side, again the pearlite, when it is completed from the austenite, if we decreasing the time period from the 0 to lesser time than the increase in time period, sorry, increase the time period, so lesser than the pearlite, then the metal structure is to be transformed from austenite into benite. Benite structure is specially one type of structure which is now see in the market, a special type of steel. It is called the benetic steel. Okay. Now in the benetic steel, if we see, there are two types of benetic structure. First one is the upper benite and second one is the lower benite. So this temperature is normally in between 300 degrees centigrade and 500 degrees centigrade. And pearlite structure is comes out from 500 degrees centigrade to a 723 degrees centigrade. Now the benite structure, when it is completed, and the time period is very fast because very less time period is required for transformation from one phase to another phase. This is the austenite structure to the sudden cooling. It is means the fast cooling. The austenite is comes out into the martensite. Martensite is a special type of structure, or normally this type of structure which is comes out from the fast cooling. It means that the fast cooling is occurs when the metal is to be impinged into the water or oil, and sudden after sudden quenching, the metal structure is to be transformed into the austenite to martensite. If we see into the below the microscope, the structure is comes out at a needle-like structure. and the hardness of the material is to be very high. And now the martensite is comes out from 100, in between 100 to 200 degrees centigrade, and martensite are divided into two types. This is the martensite start. This blue line is upper blue line. It is shown as it is MS, and lower side is called a MF, because MS means martensite is started and MF means martensite is formed. So after the TTT diagram, we have specially taken the four type of structure. First one is the perlite. It is divided into three types: coarse, fine, and medium. This is second number is the benite structure. There are also two types: upper benite and lower benite. And last one is the martensite structure. Now the question is that after martensite structure, the metal is to be again heated, because the property which is once into the endeavor property, or which is used for the industrial structure, the metal is to be again heated, and the properties comes out. It is called the tempering process. So after tempering, when the hardening material is to be again heated at a certain temperature, then the metal body, which is very much usable property like ductility or strength, this is. So after triple T diagram, now I am concluding with the again revise one type of summary. This is the temperature range from 100 degrees centigrade to 800 centigrade, and time period, it is a log time table. And by the help of austenite, after the time period, it is divided into three type of phases: perlite, benite, and martensite. Thank you.